So, caffeine, we all know about it because we all at some point needed it. But how does it work? A lot of people don't actually understand the mechanism of action for caffeine. So, behind me is a photo of what I thought was a good representation of the mechanism of action for this CNS stimulant, caffeine. So you just had your favorite energy drink. Mine just happens to be the V8 T ones. But how does it get to promote the effects that it does? Well, upon drinking it, it goes down to your stomach where it eventually enters the brain blood barrier. At that point, it then has the ability to sit and block those adenosine receptors. By doing that, most of y'all know from class we learned adenosine tends to build up and it allows the body, or it tells the brain that we're tired, we need to go to sleep. And as more and more build up, that's what kind of aids in our natural ability to get tired. With those receptors being blocked or inhibited, the adenosine is not able to bind, thus promoting, increased neural firing as well as the heightened alertness and energy that we know caffeine to give. So, in the above photo, you can see caffeine binding to these two kinds of receptors, the A1R as well as the A2AR. And what that does is it prevents adenosine from binding to those receptors. But it also, in this right portion of the photo, you see in blocking those adenosines from binding, adenosine, if it were to bind, it ultimately also allows for the release of GABA. So that GABA is also inhibited just because the adenosine is inhibited from binding as well. The second portion of this mechanism is mentioned here. It says inhibits phosphodiesterase. So in this area here, you have your phosphodiesterase being inhibited, which allows for increased CAMP levels. CAMP stands for cyclic adenosine monophosphate. And basically, it has a lot to do with our protein activity. So with the CAMPs being increased, your protein kinase activity is also going to be increased, meaning or leading to neurotransmitter release, such as your serotonin and your norepinephrine, ultimately your mood enhancing effects. Makes sense since caffeine is a stimulant. You kind of want to be in a good mood and also have the energy. So that makes sense just on a realistic level as well. The last part of this mechanism describes the mobilizing the intracellular calcium. So caffeine allows this intracellular caffeine to be released from such intracellular scores such as like the sarcoplasmic reticulum. By doing this, it aids in muscle contraction and then also synaptic transmission as well. I thought this picture did a great job of describing as well as showing not just that caffeine blocks these two receptors above here, but it also helps in muscle contraction as well as promoting those mood enhancing effects through serotonin and norepinephrine. Thank you.